-4 down here? That's -4, isn't it? That's a picture of what's going on. Are they the same? No way are they the same. That point's not on that curve, is it? So it's undefined. The square root of x graph is above the x-axis. I heard him say that means an answer for a square root is always what? Above the x-axis implies what? Positive? How on earth can you have a square root equal to a negative? You can't. So this is undefined. I mean, there is no solution. Now, one of my students was thinking of, guys, this is a little different here. They were thinking of this. Now there you can do something with that. That's not what we had here. If you solve the -4 underneath the square root, can I now deal with it and express it? Yes or no? Is that now equal to plus or minus what? 2i. Make sure you see the difference. See the difference. Now if you don't see the difference, and some of my students always check their work. I know some of you guys check your work. On that first exam, you check answers. If you did not see this going on, like Mr. Park says, there's no way a square root graph above the x-axis is going to ever be equal to a negative. That's impossible. But if you don't see that, you say, oh, Professor, do what you did there. The answer is 16. But if you take 16 back for a check, you would be saying this. And that's impossible. Is square root of 16 ever equal to a -4? No. We had that discussion, I think, the first day I met you. This, which is not up here, that's equal to plus or minus 4. But this right here with that square root symbol staring at you, that's impossible. If you see that square root symbol, they want the positive only. Okay, so I made sure I heard what he said. I thought I'd point that out before I jump into all my work here. Guys, look at my desk here, or the table. My goodness, stack after papers here, my notes here in front of me to keep me guided. We're going to get through this. I'm more than likely we'll touch upon chapter 3. Do we have a quiz tonight? What, about 10 minutes for a quiz tonight? I think all it is 10 minutes for this quiz, right? No, it's going to take me 10 minutes just to pass out the papers. Okay, so no, a little bit longer. I think it's 35 minutes I'm going to give you tonight. Now, when I score those, I'll post the scores tonight. I should see, I'm hoping that as I sit at home, grading papers tonight, that I see a 10 out of 10, a 10 out of 10, a 10 out of 10 on this particular quiz. Because the big one's coming up next Friday. The 75-point exam's coming up. Also, next Wednesday, you have what? The third quiz coming up before that big knockout exam coming up. You guys got to get ready for this. Guys, any quick questions? I thought about that driving home last night, what Park did. I thought I'd mention that to you. But any questions? I've got some handouts here for you. Do these handouts help? Yes. Okay, thank you. I did not want to post them on Canvas. I've done that in the past, and sometimes students will not look at them if they're on Canvas. I don't know why. So I'll just go ahead and bring a hard copy in. But if there are no questions in it, we do this. Part 1. See how much you recall from the end of class yesterday until now, without graphing. Starts out, no graph required. If I were a student said no graph without graphing, I'm happy. No graph. I don't worry about the graphing. Without graphing is this. They're coming here. Name the maximum, and I will abbreviate here, or minimum value of the given function. Right like that, guys. Keep it as brief as I can. So without graphing, name the max or min value of these functions. Here goes. First one looks like this. F of x is equal to, no graphing, a -4. 2x squared, subtract 3x, plus 2. I have some of these on the exam, in fact, quite also on the quiz next Wednesday. Definitely on the exam. First, I'm gonna give you partial credit. Can you tell me first, the number I'm looking for, is it gonna be a max or a min based on what you see here? Yes? Oh, hold on. Whoa, what did we say yesterday? That's why I'm trying to connect my days, I try to connect the days. Day 1, day 2, day 3. What did we say yesterday? On Tuesday, it's gonna fall into now Wednesday. Go for it.
Because A is less than 0.
Yeah, A is -2, thank you. It's less than 0. What does that tell you immediately? What does it tell you immediately? Yeah, it's going to open down. The bread always opens down if that coefficient out front's negative. And if it opens down, I'm guaranteed what? There's a max here. Not a min. So the max up here, the vertex. This is what the discussion yesterday. And the vertex is acting as a max. All they're asking me to do is to find it and no graphing. Now, can someone connect what we were doing yesterday to what do I need now? How can I find it right quickly and not touch a graph? Not go through all that graphing technique. They want to know what is the maximum of this when graph, without the graph, but when graph, what is the maximum it will go up to? It's called the vertex. Go for it.
Negative b over 2a.
Thank you. You're going to start out like that. We saw that yesterday. If I'm careful and replace the a, b, and c eventually correctly here, I got negative b, in this case it's -3. And twice a is twice a -2. Guys, all those negatives are floating around. I think it's all together will be a negative. I think it's -3 over 4. Check to see if I'm correct. Is it -3 over 4? Yep. For the x? Yeah. I think some of us are on vacation already. July 4th is Friday, guys. Let's not celebrate too early. Now, am I finished? Turn my quiz in? I'm finished and turned in? You get a 0 back? You're not finished. Now, someone tell me, now, the next part. There you go, go for it.
Plug it in for x to find the y value.
In other words, we find f of that -3/4. And if I'm careful and I go back to my original function, and I'm patient, do a replacement. Now, see, that fraction may bother us, but there it is, put back in as he suggested. Now, guys, I gotta be careful. You gotta square it first. This much is 9 over 16. You got -2 out front, or if you do a little canceling, does that give me -9 over 8 for the first term? Done. That's just arithmetic. In the middle, it's going to be a positive, and it looks like right now it's positive 9 over 4. That's in the middle. On the end, 2. And if you wish to put all this together, I use a common denominator of 8, no problem. And -9 over 8, let's make everything in terms of 8. I see a 9 over 4, let's multiply by 2, make that 18 over 8. And the 2 with an 8, let's make that what, 16 over 8. Let me step back and see if all those are correct. Are those correct? I just changed everything in terms of 8. Is that true? Add all those up on the numerators, I see -9 plus 18 is 9 plus 16, that comes at 25 over 8. I see that number coming out so many times. 25 over 8, if I have no mistake here. Coming out. Is that true? Mm-hmm. Now, please tell me, I may have graphed this one yesterday. I don't know, I can't recall. I may have graphed this one. What's my answer? What's the answer to the question? Come again.
-2 over 4, comma, 25 over 8.
You could, but if you really, I give you credit for that. If you really want to just give the answer, what is the maximum value that this function will take on no matter what x replacement you put in? You're going to say one number. What is that maximum value guaranteed to be for this function? What's the answer? 25 over 8. I realize it shows up when x is negative 3/4. That's no problem. I heard that. But right here, the y tells me that's how high it goes. So the maximum height is 25 over 8. That's the maximum y value, and that's what they want. And you're finished. Done. Now, for those of us who are ambitious, did we not come up with another formula that helped us in this process yesterday? It was a little strange, a little harder to remember than negative b over 2a. Guys, can someone tell me what that was? Was it the 4ac business?
Yeah.
Like 4ac minus b squared all over what?
4A.
4a. Now, if you apply that, you're patient, to this, 4ac minus b squared over all of 4a, you'll get this again. So if you prefer to use that formula, myself, I don't like the formula, but if you want to use it, it works. It'll give you 25 over 8. I prefer what Aiden suggested to me. Just go ahead and replace, substitute in, and find the value. You're done. Finished. Part B. We get the lessons connect here best we can. Part B. I thought also I had better, before I leave this, point this out. G of x is equal to, it's going to be a quadratic, pi x squared plus pi x, and we're on the other side of the board here, 1/4 pi for my constant. Now I want to know, don't attempt to graph this, it would graph into a parabola. No graphing. I want to know what is the maximum or minimum value that this function will take on. And someone give me a start. How would you start? In this case first, can someone recognize, is it a max value here or a minimum? This was a minimum value. I'm looking for a minimum value. And the reason is that leading coefficient, pi, roughly 3.14, pi is positive. So the parabola is opening up. You know this much about that parabola. If that leading coefficient is positive, it's opening up, I have a minimum. Now, how am I going to find it? What's the minimum value, the lowest, that this function will take on? I need to find the number. What would you do? Mr. Parker, Rena, we may have a long weekend ahead of us. I think my students are on break already. Okay. What are you gonna do, guys? I'm going right back to this. This works for max and min. So I'm going right directly back to let x be equal to negative b over 2a from the work that we did yesterday. In this case, yes, I got negative strange b. B is pi over 2 times a. Well, that's pi also. Pi's will cancel. And you end up with, be careful, a -1 understood to be on top in the numerator, -1/2. Aiden, what should I now do to find that number value I'm searching for?
Plug it back into the
As
function.
we go back to my function and find g of 1/2. So guys, if I go back and substitute in, make all this connect for us, putting 1/2 in there. Of course, I got 1/4 pi out here. Guys, if I clean this up, please, I think this is 1/4 pi itself. After you square 1/2, that's 1/4. Then I got 1/2 pi here. All right, like that. Plus 1/4 pi is my constant. This one's not too bad. If you want a common denominator of 4, 1/4 pi. Multiply this by 2, this is what, 2 over 4, I guess, pi, plus 1/4 pi. And then step back and look at it, guys, and see if all those are okay with that common denominator. Are we okay?
Is it -1?
Was it a negative somewhere? Oh, it's -1/2, it is. Where was it? Negative b over 2a, negative 1/2 here? Is that true, guys? Is it a negative 1/2? Is that what we're talking about? Okay, so here should be a negative 1/2. Put that negative sign in, that's B. Now, is everything else okay? I think I have everything with the same denominator. Guys, I see 1/4 subtract 2/4, I see right now that's a negative 1/4, plus positive 1/4 on the, what are you gonna end up with? You put all those together, what are you gonna end up with when you collect like terms?
Zero.
0. You combine all those to get 0. You guys agree? That's the lowest value that that function is going to take on. I don't care what you replace x by, you will never get anything lower than 0 to come out. 0 is the min. That's what we were discussing yesterday. Please tell me, remind me. Did we also have yesterday a couple of application problems where they asked me to find a max maybe? And we had to use negative b over 2a again. I think the word was what, greatest? It asked me to find the greatest here, which is the same as maximum. Negative b over 2a. If they actually find a minimum, negative b over 2a. That works for both. Guys, any concerns here? How to use negative b over 2a? Go for it.
So we also paying as much attention, so we're adding up 1/4 pi to 2/4 pi, to another 1/4 pi, and we get 0.
This is negative 1/4 pi here. These two put together.
Okay,
It's negative 1/4. And then you got positive 1/4 on the end.
Oh, yeah, okay, I just
It
did.
cancels out. It's true, guys? Does it cancel out to a 0? See how easy that is? Absolutely. Now, I thought, well, hold on, my students are good. They're recalling now, and I have this function, h of x is equal to, here goes. What do I do? This. Same question, that's my function, I want to find the max or the min of that function. Now, please tell me, finally we're coming back to what we were doing yesterday. Am I gonna start out with negative b over 2a again and jump into it like I did the others, just another example? Oh, I see some students shaking their head, nope, not on this one. What's wrong with it? Why can I not use negative b over 2a? I heard it. It's not quadratic. It's a cubic. Okay, Miriam, that's gonna finally lead me into chapter 3. That's a cubic. Right now, I don't know myself. My two TAs may use a little calculus right now at their desk there and find a derivative and so forth and so on and check and see what that max or min might be. And who knows, the way the thing looks, there might be 2 local max. 1 local max. So guys, at this point, no, you cannot use negative b over 2a unless it's quadratic. If it's not quadratic, forget it. You cannot use negative b over 2a, I'll just leave that. Okay, now part 2. Let's see if I'm ready for my handout here yet. Oh, I am, hang on, I got a beautiful handout here. Let's see if I am ready. I am ready. First, I need to introduce you to it. Chapter 1 ends with this. Not chapter 1. Are we in chapter 2 or chapter 1? 2? Are we in chapter 2 or chapter 1? Where are we? This is chapter 2? Okay. Here's what the chapter ends with. We say, now slow down and make sure students understand before they move into a calculus. This. Now watch carefully as I close this down with a nice handout. I know I've got students say, Professor, I'm ready for calculus. Oh, you are? Yeah, I know what absolute value is. I know what absolute value is. I'm ready. I'm ready for calculus. First, I know, you know, it looks like this. And I know, you know, somewhere back in your notes, I think I gave it also like this. Someone to recall, I think I gave it as, since you have a quiz tonight, I think I gave it also as a piecewise function. I think I gave two pieces that came together and formed that V-shaped graph we're looking for. Does anyone recall what the two pieces were? We did it one day in class. That was associated with absolute value. There's one out there handy maybe. I had two pieces to it. So I'll just write down the two pieces. Absolute value of x is equal to, absolute value of x equals 2, and I'll jot it down. Somewhere in your notes, I know it's there because we did it. Does anyone recall? Okay, got it.
Instead of F. if
X,
X,
okay, X,
if X is greater than or equal to 0.
hang on, right there. And that's in black, and we tried different marker. There was a second piece. What was the second piece?
It was negative X if X is less than 0.
Now there's a piecewise function. You got a piecewise function tonight in the quiz. We did one in the 2 o'clock session. You guys who missed that 2 o'clock session, where's Michael? Michael gave me one that had 5 pieces to it. We did a 5-piecewise function in the 2 o'clock. Was it 4 or 5? 4? Okay, 4. This one has 2. So I think right now, since you have a quiz tonight, let's remember how to sketch this. A piecewise function. Some students will say, well, Professor, they gave me the x to be greater than or equal to 0. Now, all this means is if you want to use a table to get a sense of what's going on here, no problem. Start out with 0. They gave me 0. And also, I'm allowed to try anything greater than 0. I can try 1. I can try 2. That may be enough. You can try others if you wish. What am I going to do? I'm going to take these values back here, place them into piece 1. But that's not going to be exciting because it's just x. If I replace x by 0, you get 0. Put a 1 in there, you get 1. 2 in there, you get 2. Not exciting at all. There's help for the black piece. Now, tonight when you get your quiz, and you have a piecewise function, which you do, this one looks like this. Let's sketch it. I'm starting out with 0, 0. This is an ordered pair. All right, guys, look at the first piece the way it was described to me. Am I allowed to use? Is it included? 0, 0. Now, see an equals mark in there? So here, this is to be included. I get to darken this in, 0, 0. The others, out 1, up 1, those are mine. Definitely, they are included. And out 2, up 2. Let's label it like this. That's up here. Connected. And you can try more points if you wish. I think I have enough to get a straight line, a piece of a straight line that looks like that. That's the first piece. I'm going to use this shortly. The other piece in blue says, now if you want to use a table, the nice thing about this one is they start you out with 0 again. But in that table, you're supposed to use numbers what? Less than 0. So I'm going to throw some numbers in. I know that the order here looks strange. I'm going to throw some numbers in less than 0, like -1, -2, just a variety, and start plotting points. Take those back. Be careful here. Put a 0 in. You'll get a 0. That's an ordered pair. Put a -1 in. Be careful. It's negative, then a -1, which turns into a positive 1. Put a -2 in for the blue. I think you end up with a positive 2. You guys agree? Now, when I get to the grid and start plotting these, the way the blue is represented, I'm not supposed to include 0. I don't see the equals mark. But did the first piece pick it up to begin with? So I can't reopen it. So I gotta leave it closed in. The other blue points are -1, up 1, and -2, up 2, and I'll do that here. And -1, up 1, right here. -2, up 2, and guys, you can try more if you wish, but I think I see the connection here. It's supposed to go down to 0, 0, and the second piece of that piecewise function looks like that. Is that the shape you expect for an absolute value? Of course. It's done. By the way, is all of it above the x-axis? Therefore, the absolute value, the values for absolute value coming out, answers coming out should always be what? Positive. How about the x putting inside here? Am I allowed to put any number I wish inside? That's the domain. It's the domain from left to right, the way the scratch looks, a negative infinity through positive infinity. The range, though, the up and down, the furthest it drops down is 0. 0 to infinity is the range. You've got that. You'll say, well, Professor, how are they going to end this chapter with doing this? Well, here goes. And then we'll get this handout to you. I think it's beautiful. Here we go. First, on the side, before you get the handout, solve this. Absolute value of x is equal to 5. Find the x. One of my colleagues would walk in and say, "Ray, you showing them that?" Yep, I'm showing them that. Guys, the answers are? What? Yeah, thank you. What can I replace x by to get a 5 to come out? And I'm hearing the students say quickly, Professor, my goodness, just by observation. You can replace x by either a +5 or a -5. The absolute value will come out to be a +5. Reason? If I go out to a -5 on this grid, is it possible to go up to 5? And stay on that blue graph? Yes. This way out to a +5, she's telling me, go up. Is it possible to go up and be on that graph? Absolutely, at 5. There's 2 answers here. I would expect 2 answers because I had 2 pieces on this. Number 2, or letter B, before you get the handout. I'm anxious to show you what's going to happen here. B looks like this. Absolute value, oh boy, yes. 3x minus 1 is equal to 2. Solve for x. Keep in mind, I have it staring at me. This is a 2-piecewise function. So there must be 2 parts involved here. Can anyone tell me the first part that you would set up as a good solid student find, try to solve for x? Go for it.
3x minus 1 equals 2.
Thank you. So I'm going to call this number 1. He says, Professor, you may consider inside there could be equal to a 2. Guys, that means if this were empty, which it wasn't, but if this were empty inside, you could definitely place a 2 there to get 2 to come out. And there's another one. What's the other one?
3x minus 1 equals -2.
That's exactly what I'm looking for. Again, it's 2 pieces. So inside there, if it were empty, it could be a 2 or a -2. But the absolute value of both of those will give you 2. And inside there was 3x minus 1. Guys, easily done here. I'll solve this right quick to save me a little time. I think it's 1. Do not let me make a mistake here. This one I think is -1/3. I'll do that real quickly. I think it's -1/3. Guys agree? I'll solve those 2 right quickly. Okay, so if this is correct, I would think the answers are these numbers. And this, since this one's fairly basic, I'm gonna take it right quickly. If I go back and put a 1 in here, 3 times 1 is 3, 3 minus 1 gives me a 2, absolute value of 2 is 2, checks. If I put this strange -1/3 in there, right there for x, 3 times -1/3, 3's cancels like a -1. -1 minus 1, -2. But the absolute value of -2 turns into +2. It checks. No problem. We're finished. That's 2 answers. So what on earth could be hard about this? I don't think anything. But let's try another one here before we get this handout. In fact, I've taken these examples directly from your handout when you finally get it. Now this one. And then we'll give you the handout. Looks like this, and this is equal to 12. Solve for x. mind, this is why I did this. It's a two-piece situation going on. Now, we're doing my work at the top, we're running out of space there. Guys, number one, please tell me, what do you think the equation could be written as for the first piece? Yes, go for it.
X squared plus x minus 12 equals 0.
Hang on now, x squared plus x equals 12. 100%, I agree with you. Now, since you're telling me all these beautiful answers, how about number two?
X squared plus x equals
Is it equal to a negative 12?
Yeah.
I think I heard. He's exactly right. That's all it takes. You can either have a 12 or a negative 12. Now, may I solve this? Yeah, these are quadratics. On the first one, move the 12 over. Put it in standard form. Guys, I think this one factors. I think. Does it factor?
Yeah.
And then split this up, and I think that implies negative 4, 3. Okay, I have two answers. Now let's try to solve number 2 that he gave me, which is also to be considered. Let's move that 12 over, put it in standard form. Now you have this. I don't think that one factors. So I could turn to what for help? Quadratic formula. Negative 1 plus minus square root, b squared will give you a 1. 4 times a times c, put them in quickly, all over 2. If all that's done correctly, negative 1 plus minus, I think underneath there is 1 subtract 48. I think. Which is negative 47 over 2. Where's my original problem? My goodness, oh, it's down here. Then what am I going to do now on that second consideration? Use quadratic formula. It gave me some strange numbers to look at, like a square root of a negative what? 47. So what might you want to do? Okay, now we've been discussing I. That's why I brought this in on the handout. We've been discussing I's. I could put an I in there easily. This one, I can do this now. And I don't know whether we're going to accept it or not, but I can put the I in there. Here we go. This is equal to negative 1 plus minus, guys, the best you can do is I radical 47 all over 2. You can do that. But guess what? When I start checking, in other words, if I take 4 back down here, am I supposed to take 4? What was 4? Oh, I'm on the one. Oh, negative 4. If I take negative 4 down here and plug it in, does it check? Let's see if it does. Negative 4 squared is 16. 16 plus a negative 4 is what? 12? Is the absolute value 12? Does it check? Is it 12?
Yeah.
So I know quickly that one checks. If I put a 3 in there, 3 squared is 9. 9 plus 3 is what? 12 again? Absolute value 12, that one checks. What would you say was the last two? What might you tell me? We went ahead and wrote as I radical 47. But what might you tell me about it?
It's not a real solution.
There's not a real solution. I cannot, I'm going to put imaginary numbers inside absolute value. They go on to Stanford in their math program, they may do it. And they may be into another whole world of math. I'm not going to do this. I'm not going to scare you. Okay, so we're going to not use those I's. We have them over there. The only numbers we're going to use for an answer, a solution here, are the real numbers that came out. -4 and a +3. We will not be using the i's. It's a good thought for you guys who like to think like this. And go on to Berkeley or Stanford and see what they say about it. Absolute value of I. I'm not gonna say anything about it. I'm scared. Takes you to another world altogether. Different symbols to work with. I'm not gonna work with that. Now, I've got the handout. I saved a couple for you guys, but we're gonna discuss that. I'm gonna erase all this. After all that business there, darn it, I'm not gonna use it. Let's get this done. Mr. Park, Rena, guys, I need you. Find my papers here first. Yeah, here they are. See if we have enough here to get these students 1,